Let's see if we can use our calculus to graph this equation. So we have y equals x over 1 plus x squared. So first things first, we need to do our first derivative test, which means we need our first derivative. So that means we need y prime. Well, this is a quotient, so we have to use our quotient rule. So our quotient rule says the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over our denominator squared. All right, well, let's see if we can clean this up because somehow I have to try to get this to factor or have zeros or figure out some intervals for increasing and decreasing and set our first derivative equal to 0. So let's see if we can figure this out. Well, I'm going to clean up that numerator a little bit. So that looks like it'll give me 1 plus x squared minus 2x squared all over 1 plus x squared squared. So let's keep cleaning. Looks like that's going to give us 1 minus x squared all over 1 plus x squared squared. All right, so we're not going to get any zeros from the denominator here. If we take that denominator and set it equal to 0, we'll be taking the square root of a negative, and we can't do that, so it would be imaginary. So there will not be any zeros coming from the denominator. So that means the only zeros that we're going to get from this one are going to be from our numerator. So where are we going to get 0 in the numerator? So it looks like we'll have 1 is equal to x squared. So it looks like positive or negative 1 will be equal to x. So we'll have two places that we need to break our interval for this one. So if we go to make our first derivative test table, we need our interval. We need our first derivative, and we need to see if it's increasing or decreasing. I'm going to break my interval in two places. So here's 1, 2. The first one's at -1, and the second one is at 1. So that means my interval is going to be from negative infinity to -1, -1 to 1, and 1 to infinity. All right, let's check it. So go ahead and pause and pick your values and put those in and test your first derivative. Remember, you're testing it in your first derivative. So right here, pick your numbers and put them back into your first derivative. All right, did you test it? I got negative here. I used 0, that's my favorite. I got positive when I used 0, put 0 back in. And here I got negative. Is that what you got? So let's see, we'll have decreasing, increasing, decreasing. So that means this is our min, and then this is our max. So we need to figure out the other half of our coordinate. So when we have -1, we need the y value, and when we have 1, we need the y value. So if we take -1 and put it back into our original equation, it looks like it's going to be -1 over 2. So that will be -1/2. And if we take 1 and put it back into our original equation, it looks like it would be 1 over 2, so half, so 0.5. All right, let's put those on our graph. At least it's something that we can start with. So -1, -1/2, it's right there. And then we have 1 and +1/2. It's right there. All right, we got that part. So now we need our second derivative. We're going to need some space for the second derivative. Usually I do it right to the right of the first derivative, but this one's a quotient rule. I'm going to need some space to write it out. So I'm going to put my second derivative over here this time. So the second derivative is going to look like denominator 1 plus x squared quantity squared times the derivative of the numerator, which will be -2x. And we're going off of this one right here. And then minus. So we have bottom times the derivative of the top minus the top times the derivative of the bottom. But now you got to do a chain rule. So don't forget, because we have that squared, we have to do our chain rule. So we have 2 and then rewrite. And then the derivative of the inside. There we go. See why we needed a little extra space? All over our denominator squared. There we go. All right. Well, let's see what we can do here. I see a 1 plus x squared in common everywhere. So let me pull that out. See if I can clean it up a little bit so that we can make some sense out of this. So 1 plus x squared, I'm going to pull that out. I'm going to do a big parenthesis, which will leave me 1 plus x squared times negative 2x minus 1 minus x squared times 4x. Okay, big parenthesis. And then that's all over our denominator. So if you look right here, I had the 1 plus x squared right here, and I have 1 right here. So I pulled those to the front here, and that will let me cancel this and one of these. Now, if we do some distribution and some distribution, we can clean it up a little bit more. Negative 2x minus 2x to the third minus 4x plus 4x to the third. Can't really do anything about that denominator. But that will clean up the numerator to become 2x to the third minus 6x. And then that denominator's just stuck. Okay, well, that's not too terribly bad. So let's see if we can finish it from there. So I'm running out of space going down that way. So I'm going to finish it up here. But we need to take our second derivative and set it equal to 0. So 0 now is going to equal our 2x to the third minus 6x all over 1 plus x squared to the third. We're not going to get any zeros out of that denominator. The only way we're going to get a 0 is from the numerator. So if we look at 0 equals 2x to the third minus 6x, we can pull out a 2x. And that will leave us with x squared minus 3. So 0 is equal to 2x, and 0 is equal to x squared minus 3. Which means if we solve this down, we get 0 is equal to x, and we get x is equal to the positive and negative square root of 3. All right, there's a lot going on here. We have a lot of inflection points, so we need to test all 4 of these. We're going to need some space over here. There we go. So I'll put my interval here. We need a second derivative, and we're looking for concavity. All right, here we go. I have 3 inflection points, which means I'm going to need to break this 3 times. All right, so here we have negative root 3. Here we have 0, and here we have positive root 3, which makes our interval negative infinity to negative root 3, and then negative root 3 to 0, and then 0 to the square root of 3, and the square root of 3 to infinity. That's a lot of intervals to test. All right, I'll be quiet for a minute. You go ahead and test those intervals, pause the recording, and jump back in once you have them checked. Did you test your intervals? I got negative, positive, negative, positive, which means we're concave down, concave up, concave down, concave up. So the second derivative on this one was pretty intense, but that's all right. We figured it out. All right, if you take your intervals, your inflection points, and you use the x value and put it back into the original equation, you can get the y value. So I'll go ahead and write these in. I did it as decimal because for me that makes a little bit more sense when I'm trying to plot it on the graph than using square root of 3. So like square root of 3, for example, is negative 1.7. So I would use that instead, just as a preference, but it's personal preference. So you can do it however you like. But that's why I'm using the decimals for these. Okay, so here we go. These are our inflection points, and we're going to change our concavity quite a bit. So let's see here. So negative 1.7, so right about there, and then positive 1.7, and positive, almost. There we go. All right, now let's see if we can do this. So we need to let me change colors. I'll put it in blue. We need to have it decreasing from negative infinity to -1, and we need to be concave down. So it looks like it's going to go like this. Concave up, squiggle it through, concave down. There. I think we got it. And there is our sketch for this one.